Hi guys, I'm a third-year PhD student at Price, and today I'll be presenting a report that's still in the works. It's co-authored by Marlon Bornat, Raphael Bostic, Severdnyaski, and Alan Prohovsky. As always in papers like this, I need to say that all the opinions expressed here are of the authors and do not represent that of the Federal Reserve Board or the California Franchise Tax Board. Sorry, Federal Reserve Banks. So gentrification and displacement are like hot topics. I know the conference that I'm presenting at ACSP, on the morning of, in the first day, there are at least 4 talks dedicated to gentrification, right? And I'm presuming all of you here are excited to hear about gentrification, so it's hot. One thing we do know is that gentrification is a more nuanced story that perhaps we often tell. For example, we know that whether house prices change or demographics change, right, all depends on a lot of these factors. What a lot of these papers don't do, however, is use microdata. So when a lot of these papers, what they do is they look at either census tracts and aggregated data from that and see how the census tracts change, right? Our advantage, on the other hand, is that we have microdata. So we observe individual people year to year in LA metro station areas. So we know specifically where they moved, when they moved, their income, and so forth, right? That's a luxury that these papers do not have. And it also eliminates a lot of potentially endogenous factors. So we essentially can more or less directly observe whether real stations impacted mobility or not. So we have data from the California Franchise Tax Board on all tax filers who filed in LA County between 1993 and 2013. For some of these households, we have 9-digit zip codes, so not all of them by all means. And using these 9-digit zip codes and a database from Geolytics, we were able to attach lat-long data and place these households near, or determine whether these households are near LA metro station areas or not. Because we have data on basically where they live and their income, we're able to compute the income distribution in each station and year within the half-mile radius of LA metro stations. We're also able to compute the in-out mobility for households across income distribution. So basically the rate at which they move into the rail station and the rate at which they move out of the rail station, right? I forgot to mention here we also compute the net mobility. Net mobility is basically the in mobility minus the out mobility. And then we're using these estimates, we're able to test whether rail station had any effects on mobilities. So our findings are as follows. We do observe that there is an increase in the number of households near LA Metro rail stations. Of course, the issue with our data is that our data improves over time across numerous dimensions, including more people filing, higher fidelity in terms of geography and so forth. But in the census data, we also observed that the number of households actually does increase in LA metro stations. Unfortunately, with our data, we can't separate necessarily the two, at least not yet. Our second finding is that over 75% of households in LA metro stations or near LA metro stations are low income, that is households making less than 80% of the local media area, of the area median income. And that shifts year to year a little bit. And then there is some evidence that we have a decrease in the share of extremely poor households or households that earn between 0 and 30% of AMI. Over time from 39 to 33% between 1995 and 2012. So it's not a huge change, but it is a change. And I'll just elaborate more on that. We're also able to, when we're testing whether rail stations had any impact on mobility rates, we're able to see that rail station openings did not really impact whether higher income households move in or out and any rates of the sort. So we can pretty much cross out one of the reasons why we would see kind of displacement of the extremely poor, right? So as a result, we kind of hypothesized that the reason why we do observe a kind of a decrease in the number or in a share of extremely poor in LA area in LA stations is that either LA stations are or metro stations are located in already gentrifying areas, so they would gentrify regardless of the metro station, or the incomes of households who reside in those areas have risen, right? And again, we can't really test these two with the present data, but we'll be working on it. Finally, kind of the interesting story here is that canonically, right, we hear that higher income households displace lower income households. Here we get a somewhat more complex story. Namely, we find that the opening of a rail station decreases the rate at which the very poor and the poor households move out of LA metro stations, right? And we don't know if it's a direct result of that or not, but there is also evidence that the extremely poor households don't move into the rail station areas. So essentially what's happening, or what we presume is happening, is that the very poor and the poor are not moving out at the same rate as they normally do, so they're not vacating the units, and the extremely poor are not able to move in. So this is kind of the displacement story. The note, it's not really, it's more of like housing turnover rather than displacement. So we test over the LA Metro. There are 94 stations. 44 of them opened between 1993 and 2013 along the Expo, Gold, Green, and Red lines. For the Red line, we actually combined, because there's so much similarity between the two of them, overlap, we just combine them and treat the red and purple lines as the same line. The blue line that goes over here, all stations for that line opened before 1994, so we don't actually, we don't test that line at all. And then there are some stations along the Gold and Expo lines that opened after 2013. We also don't test those. Because we have tax filer data, we don't really know whether the tax filer data is representative of the number of households that are actually in the LA Metro stations. So in order to just do a quick check, and this is a rough check of whether our data is representative of the households that live near LA Metro stations, what we did was, if we look at 2010, we looked at the number of households that reside near LA Metro stations as determined by the census block, and the number of households that reside in LA Metro stations as determined by the census block group. So they kind of provide the upper and lower bound, mostly because the block groups are large, so they're most likely extend beyond the radius and thus overcount the number of households. Of course, our data are not perfect. As I said earlier, the number of households for whom we have 9-digit zip codes is not complete. Only about 53% of households in 2010 had 9-digit zip codes attached to them. Of those households, we only had about 80% that appear in year T and T+1. This is a requirement that we need to establish whether a household has moved or not. Of that, another cut to the data occurs because we don't have lat-long data for all 9-digit zip codes. Only about 90% of households have, or 90% of 9-digit zip codes had lat-long data. And finally, according to the California Tax Board, only about 80 to 85% of households file taxes in a given year. So we use the lower bound of 80%. So all of this, we call this the attenuation rate, or the portion of data that's lost. So we shouldn't really expect the data that's lost to be represented by our data. So we multiply this proportion by the number of households we found using census block groups and blocks. And in 2010, at least, we find that according to census block groups, 150,000 households in the area. According to blocks, it's 111,000. We fall right in between at 125,000. So this is one suggestion that our data is quite representative of the number of households that are in the nearest stations. Of course, as you can see, that the estimate changes. Sometimes we're within the range, sometimes we're not within the range. And then also just the data that we have available from the census is not complete. right? So for example, we use the 2010 number for all years here, which likely also contributes to kind of where the numbers fall in. But as a rough estimate, I think we are pretty good. Since we're not only concerned about the number of households, but we're also interested in the income distribution among those households. This is kind of like the main criteria, right? We also compared our data, I would call that FDB, to the census, to the data that's reported in the census and the ACS samples. So this reports the difference between the census and ours. So for example, here we see minus 3%. That's the percentage difference between the proportion of households that earn below $10,000 in the census and the proportion of households that earn below $10,000 in our data, right? So in general, we actually see that we're pretty close in terms of our income distribution. We're generally within 1 or 2% for most income groups. What we do see, especially in the earlier years, is that we're somewhat underestimating the number of low-income households. That could be a factor of many things, including the fact that we're using the year 2000 block group income distributions, especially earlier in that years. Then there's also the fact that low-income households simply don't have to file taxes, right? So they'll only file if they want, if they can maybe receive benefits, and even then, not all of them file, right? So it's not unnatural for very low-income households to be kind of underrepresented in our data. Nevertheless, I think we're pretty close. So we divide, because we want to consider, we want to see how different income groups are impacted. What we do is we divide, I'll of course change the slide later on, but we divide our households into 7 different income groups. We want to kind of see how the low-income groups are impacted and how by the higher income groups. So we use HUD's definition of poverty, namely it's defined as a percent of AMI. So the extremely poor households are those that earn between 0 and 30% of AMI, which is basically 0 to $20,000 a year. The very poor households earn anywhere between, or those that earn 30 to 50% of AMI. The poor households are those that earn 50 to 80%. And then we also look at the upper middle income and upper income. These are somewhat arbitrarily defined, but nevertheless helpful. And we played around with the upper bound. So the upper income households are those that earn 200 to 300%. We played around. Even if we increase this to 400 to or 500%, the results don't change very much. And there's also the negative earners, the households that actually report negative income, those earning between negative 100% of AMI and zero. We actually think these are kind of entrepreneurial or self-employed households that report more losses than, I guess, income during a given year. So even though they are negative earners, we should actually consider them to be part of the higher income group. We should not be thinking of these people as being necessarily poor. And finally, there are households that earn below 100% of AMI, and there are households that earn above 300% of AMI. In any given year, though, that proportion of households represents less than 2% of all households within our data. So we're not too concerned. And again, it doesn't really impact our results very much. So here we have 2 graphs of the snapshots of the income distribution across the years. If we look at this graph right here, see that in 1994, about 42% of households in LA metro station areas were extremely poor, that is earning between 0 and 30% of AMI. By 2003, that share has decreased down to 29%, right? So what we see is that basically the share of extremely poor households has decreased in LA station areas. We also see that the share of upper middle income households has increased from 5% to 13%, right? So there is kind of evidence of the income distribution shifting away from lower income households. However, right, if we compare 2003 to 2012, we actually see the exact opposite story, right? So the number of extremely poor households has increased from 29 to 33%, right? and the number of upper middle income households has decreased from 13 to 12%. So this kind of intends to show two things. A, there is evidence that there is some evidence that the share of low-income households has decreased in station areas. But again, it depends on what base year we compare years to, and that there's also a lot of volatility from year to year that these graphs are not really showing. What is kind of promising is that when we look at the LA County in general, this is this graph right here, we actually see that between 1994 and 2013, the number of households earning less than $10,000 and then less than $15,000 has decreased substantially in all 3 years, right? Which is somewhat, so if we do observe a decrease in the number of low-income households near rail stations, it's also consistent with the pattern that we observe more generally in the LA County. I guess one thing I forgot to mention, 1994 for us is an interesting year because that's the first year that we got data for. And the data quality is not always the best, right? So some of these changes may also be a result of improved data quality. But in general, what we can take, there's a couple things that we can take away. In any given year, again, over 60% of households are low-income households. This should be changed to 75%. We also see that, or there's some change away from lower-income households. And then we posit that these changes can be for three things, as I mentioned before. A, the income of households has increased. That's why we see the number of extremely poor households, the share of extremely poor households decreasing. We could also observe this pattern because stations opened in these areas and gentrification happened, and that's why we saw a decrease in the number of share of low-income households. Or we could observe this because the stations are located in already gentrifying areas, and this would have happened regardless of whether a station opens or not. So we test this with this model, and indirectly we're also able to look at number two, because basically if this suggests if the opening of rail stations does not have any impact on mobility rates, then that kind of suggests that the income distributions are changing, not because higher income households are moving in as a result of TOD, but rather it's already happening and has been happening, regardless of the stations. So this is, I guess, this is the specification. We test, we fit this regression to each income bin. So we have 7 income bins. We fit this regression to each one of them. R is the mobility rate. Here, for succinctness, we omitted the in, out, and net, but this basically, and we test that separately too. So R includes mobility in, out, and net. We also include a station fixed effect. We include a time fixed effect, and we include a, and this is the dummy for whether a station opened in that particular year. So beta is the estimated impact of the station opening on mobility rates. So our results are as follows. We also estimate this regression for all households combined, but we don't report that in this because I guess in the actual conference we'll have a lot less time, and it's not as interesting. But the regression results are disaggregated by income are pretty interesting in themselves. First, we see that the extremely poor households are moving, or they change the rate at which they move in once a station opens, on average by about 1% every year after a station opens. So this just basically suggests that once a station opens, extremely poor households don't move in at as high of a rate as they used to before the station opened, right? When we look at the upper middle income households, we also see that they move in at a smaller rate than they did before the station opened. So usually the story that we tell is that the higher income households displace lower income households because they move in at a higher rate. Here we see the exact opposite, right? So this is not evidence of displacement by higher income households. The other things we see is that the out mobility rates were impacted for the very poor and the poor households. So once a station opened, the very poor households decreased the rate at which they move out of a rail station by 1%, and the poor households, those are earning between 30 to 50 or 50 to 80%, they also decreased the rate at which they move out of rail stations by almost 1%, right? So what we hypothesized, given the results, well, we explain these results in the following way. First, it seems that the opening of a station induces households to stay instead of moving out, right? So households kind of like hold on to their areas, to their location, to their residence. There is also evidence that the poor and the very poor households displace the extremely poor households. So in essence, it's the poor households that compete for units in station areas. Again, there is no evidence that upper or higher income households displace lower income households. And in general, the opening of rail stations does not impact the mobility of higher income households. So all of this basically suggests that because higher income households are not impacted, and because the competition happens mostly among low income households, that stations are or seem to be locating already in gentrifying areas, or there's an omitted bullet point here, but or that the incomes of the residents are increasing. We would also like to mention the fact that our beta coefficient over here is likely an underestimate, mostly because this is a dummy on the year when a station opens, right? But of course, rail stations don't open randomly. We know that they're being opened, right? So there is probably development that happens before a rail station actually opens, and then once it does open, the development of a community is likely protracted over time, right? So all of these things will suggest that the beta coefficient likely is biased towards 0, so that if there is an impact on mobility rate, it's probably a bit higher than what we're estimating. So the magnitudes in this regression could be a tad larger. What we also kind of recently bumped into, as of like this morning, is that our out mobility rates may be a tad too high, and we're still looking into that. But that may also impact how our estimates are, how these results will look like. And then, yeah, in further work, we'll test our identification strategy by changing the year to a placebo year and the station to placebo years. We can also examine the cumulative effect, right? So in this regression, what we observe is kind of so for example, if a station opened in 2000, then this is the average year, the average annual effect on like the year after 2000. So on average in 2001, 2002, 2003, 2014, and so forth, the net mobility will decrease by 1%. What we can do is kind of disaggregate that into both cumulative effects and annual effects, and look at how mobility rates are impacted cumulatively and year by year. We also are able to look at so we keep mentioning that it could be that the incomes of households living in metro rail stations are increasing. We can actually directly test that. So that's also left for future work, and then we can also exploit the macro data directly, but that's a more technical note. Thanks so much.